All right, the topic for today is simplifying radicals, and we're going to be doing this using the properties of radicals. So we're going to start by covering what the properties of radicals are. They're really easy, and once you get the hang of these, it's pretty easy to simplify radicals. And the better you know your multiplication tables, the better you're going to be at this. All right, so first of all, we have the product property. And what that says is if I have two roots and they have to be of the same index. Remember, the index is that little number right here? Well, this is a square root and this is a square root. If they are the same index, you can just make them one root by multiplying this by this. Okay? Now, this also works in reverse. So if you have this, you can split it up into two separate radicals with a multiplication sign between them. All right? The quotient property works just like the product property, except it's for division. If you have one root divided by another root and they're the same index, all right, so in this case both square roots, you can put them together underneath one root symbol, so one radical sign. And keep in mind, if you have this, you can go backwards and you can split it up into the top root divided by the bottom root. Now you may wonder, why would I do this? And I'm going to show you how you're going to use this to simplify radicals. So let's talk about what simplifying radicals means. Simplifying radicals means doing both of these things. Number one, we're going to factor out any perfect squares. And we talked about what perfect squares are. Perfect squares are like 1, 4, 9, 16, 25, 36, 49. Those are perfect squares. So we're going to factor out any perfect squares and then rationalize the denominator if we have a denominator. Okay? Well, I will show you how to do this. And what this means is removing square roots or cube roots from the denominator. When you're simplifying a root, you can't leave a root in the denominator of a fraction. You have to get rid of it. All right? So that's what we call rationalizing the denominator, and we're going to learn how to do that today. Now, some of these problems are worked out for you here, so you can just watch. First of all, let's take a look at A. I want to simplify the square root of 98. What I need to ask myself is, in order to simplify this, what perfect squares divides evenly into 98? I may not know that right away, and that's when a calculator comes in handy, but I do know my perfect squares. All right? One of the perfect squares is 49. 49 is 7 times 7. It happens to go into 98 two times. So I'm going to use my product property in reverse, and the square root of 98 is the same as the square root of 49 times the square root of 2. Now, we learned yesterday that we can find the square root of 49. Since 7 times 7 is 49, the square root of 49 is 7. And the simplified form of this radical is 7 square roots of 2. All right? This is what we're going to be doing today. So let's take a look at B. All right? B is a fraction. Here's what we're going to do with this. We're going to use our quotient rule in reverse, and we're going to divide this into two different radicals. One on top, the square root of 3, and one on the bottom, the square root of 25. The square root of 25 is something we can simplify. The square root of 25 is 5. So this becomes the square root of 3 over 5. That's the simplified form of this particular radical. All right? Now, let's take a look at C. Square root of 36, x to the third. What I want to do here is use my product rule in reverse. And what I want to think of is what divides into this that is a perfect square. 36 is a perfect square, but x to the third is not. Now here's what I can do. X to the third is the same as x squared times x. And x squared is a perfect square. So I'm going to split this up into 36, x squared, and x. And it's going to look like this. Square root of 36, square root of x squared, and the square root of x. And when I multiply all these, I get 36x to the third. The reason I'm breaking it up this way using the product rule is because the square root of 36 is 6. The square root of x squared is x. And then I have the square root of x left over that I can't simplify. And so it's going to look like this. 6x square roots of x. All right? Let's take a look at D. All right? When I look at this, these are cube roots. I don't know what the cube root of 25 is, and I don't know what the cube root of 10 is. These are not perfect cubes, so it's not easy to do these. Here's what I'm going to try. I'm going to use my product rule and write these together under one cube root. So this is the cube root of 25 times 10, which is the cube root of 250. Now, let me ask myself, are there any perfect cubes that go into 250? And remember, we have to memorize the first 5. That's 1, 8, 27, 64, and 125. 125 goes into 250. So it goes in twice. So I'm going to use my product rule in reverse, and I'm going to write this as the cube root of 125 times the cube root of 2. All right? I can simplify the cube root of 125. The cube root of 125 is 5. So this equals 5 times the cube root of 2. All right, let's take a look at E. This one is worked out for you. I have the square root of 60 over the square root of 5. All right, here's why I'm going to do what I'm going to do. I want to put these under one square root using the quotient rule. And the reason why I'm going to do that is because guess what? 60 evenly divides by 5. All right? May not be the best move if it doesn't, but since it does, this is going to allow me to simplify. So I'm going to put it under one square root, 60 divided by 5. Now I'm going to do that division, and 60 divided by 5 is 12, so I get the square root of 12. Now I want to use the product rule and simplify this. So I ask myself, what perfect square divides evenly into 12? And the answer to that is 4, which is 2 squared. So I'm going to split this up into 4 times 3. So write it as the square root of 4 times the square root of 3. The square root of 4 is 2, so this becomes 2 times the square root of 3. And the square root of 3 doesn't simplify any further because no perfect squares divide into it. All right? Let's do this. Let's take a look at F. This is a cube root problem. Here's what I'm going to start with. And sometimes you have to play around with these to figure out what's going to work. But let's use our quotient rule and split this into 2 separate cube roots. I'm going to have the cube root of x to the 5th in the numerator and the cube root of y to the 3rd in the denominator. All right? Now, what perfect cube goes into x to the 5th? Well, here's what I know I can simplify. I could simplify the cube root of x to the 3rd. That's x. So I'm going to split this up into x to the 3rd and x squared. That'll give me x to the 5th. So the cube root of x to the 3rd times the cube root of x squared over the cube root of y to the 3rd is easily simplified. This is y. All right? In my next step, I'm going to simplify the cube root of x to the third, which is x. So what this simplifies to is x times the cube root of x squared over y. I can't simplify the whole thing, but I'm simplifying as much of it as possible. Let's take a look at g. G is a square root, and I have to think about what perfect squares divide into 18 and m to the third. So into 18, I can do this. How about 9 and 2? Because 9 is a perfect square, 3 squared. So let's split it up into 9 and 2. So the square root of 9 times the square root of 2. And m to the third doesn't have a square root, but let's split it up into m squared times m. Because m squared can be, square root of m squared can be simplified. So square root of m squared times the square root of m. All right, let's go through and see what out of this we can simplify. All right, so first of all, square root of 9 is 3. Square root of 2 won't simplify. Square root of m squared is m, and the square root of m won't simplify. Here's how I put all this together. Take the things that aren't under the square root and multiply them first. So 3 times m. Now use your product rule and make one square root. So this is the square root of 2m. All right, let's take a look at h. We're going to do the same thing with h. We're looking for what divides into this that has a square root. Now the square root of 2 can't be simplified, but guess what? I can take the square root of a squared. So let's split this up using the product rule. Make this the square root of 2 times the square root of a squared times the square root of b. Now out of this, the square root of 2 doesn't simplify. The square root of a squared is just a, and the square root of b to the 1 power doesn't simplify. All right? Bring out everything that's not under a root symbol to the front. So bring out the a, and then under the root sign, use the product rule to multiply the 2 and the b. So a square roots of 2b. All right, let's go to the next page. Now, here's where the problems become a little bit more complicated, and we may not all do these the same way, all right? We may do these different ways because now we have options, all right? So here's what we can do with this particular situation. I have this root times this root. Here's how, if I were going to multiply these, here's how I would do that. I multiply what's outside the square roots. 5 times 3 is 15. All right? What's under the square roots, I'm going to use the product rule. And I have 24 times 8. That gives me 192. All right. I want to simplify the square root of 192. So I need to ask myself, what perfect square divides into this? Okay, and I have to keep in mind what my perfect squares are. I've got 1, 4, 9, 16, 25, and so on. I may have to go a couple rounds with this if I don't pick the biggest one first. So let's see about this. I'm thinking I'm going to try 4, but just in case I can go bigger, I'm actually going to try 16. So I'm going to take 192 divided by 16, and it does divide. 16 times 12, all right? So I'm going to split this up. I've got 15. I've got the square root of 16 and the square root of 12. here's the interesting thing. I happen to know from a problem we did a few minutes ago that I can simplify the square root of 12. All right, 12 is 4 times 3, and 4 has a square root. So I'm going to actually split that up further. So 15 times the square root of 16 times the square root of 4 times the square root of 3. Now, I'm going to leave my 15 alone. The square root of 16 is 4. The square root of 4 is 2. And then I have the square root of 3. My last step here will be to multiply 15 times 4 times 2. And that's 120. So this is 120 square roots of 3. All right? If I take a look at B, I know I can simplify the square root of 12 because it just came up in my very last problem. But let me point out before you go that route how things can be really easy if you just leave your mind open to different possibilities. Let's use our product rule and multiply the 12 times 3. 12 times 3 is 36. So this is the square root of 36, which is just 6. Now, it's problems like C that are always kind of tricky. Here's the issue. Students look at this and think it must be 2A plus 2B. But that's not how it works because there's no addition rule for radicals. Okay? It's a product rule. So we have to find out what the products are that this is made up with. And guess what that means? Factoring. Okay? So here's what we're going to do. We're going to factor. And this, we can factor out a greatest common factor of 4. All right? So use our product rule, and that will give us the square root of 4 times the square root of what's left, which would be a squared plus b squared. All right? Now, I know a squared plus b squared doesn't factor because there's no factoring formula for the sum of two squares. But the square root of 4 is 2. So this is 2 times the square root of a squared plus b squared. And I can't take the square root of this. All right? It's not something squared. It's a squared plus b squared. If I had something like this, if I had this, then this would equal the square, or equal, I'm sorry, let's not put the square root there. This would equal a plus b. But that's not what we have. We have a squared plus b squared. I can't factor it, so I can't take the square root of it. All right? D is where we're going to get into our second objective for the day, which is rationalizing the denominator. I can't divide 5 by 3. All right? So here's what I'm going to do. I'm going to use my product rule and write this as two separate square roots. Square root of 5 over the square root of 3. I can't simplify the square root of 5 and I can't simplify the square root of 3. But when you're simplifying, you cannot leave a square root or any root in the denominator. All right? I need to get rid of that. The interesting thing is, and we remember this from yesterday, if I happen to have this, the square root of 3 times the square root of 3 equals just 3, right? So here's what I'm going to do. I'm going to take my fraction and I'm going to multiply it by 1. But my 1 is going to look like this. The square root of 3 over the square root of 3. Because anything divided by itself is 1. All right? Here's why I'm going to do this. Use my product rule and what I know about multiplying fractions, and I'm going to multiply these two on top, and I get the square root of 15. I'm going to use this on the bottom. Square root of 3 times square root of 3 is 3. I no longer have a square root in my denominator. So this is the simplified form of this expression. All right? So let's take a look at E. All right? I have 9 times the square root of 5 over the square root of 27. All right, remember, when you're splitting this up into 2 fractions using the quotient rule, this is really 9 over 1. So the 9 goes to the numerator. All right? So on top, I've got 9 times the square root of 5. On the bottom, I've got the square root of 27. The interesting thing is, I can simplify partially the square root of 27. It's 9 times 3, and I can simplify the square root of 9. So here's what we'll do. 9 times the square root of 5 stays the same. And this is going to be the square root of 9 times the square root of 3. I can simplify the square root of 9. So this is 9 square roots of 5. The square root of 9 is 3 square roots of 3. Now I can actually simplify my fraction because outside I have a 9 and a 3. 3 goes into itself once and into 9 3 times. So here's what I have. 3 square roots of 5 over the square root of 3. But I cannot leave a radical sitting in the denominator. So this is the square root of 3. I'm going to multiply by 1, but my 1 is going to look like this. Square root of 3 over the square root of 3. In the numerator, when I multiply this, I have the 3, and then I have the square root of 15. On the bottom, the square root of 3 times the square root of 3 is 3. All right? Guess what? These 3's now cancel. And this just gives me the square root of 15. So you can see some of these are going to take a lot of steps. Let's take a look at F because it's a cube root, and it's a little bit harder to rationalize the denominator when you have a cube root. So let's just take a look and see what we've got. First of all, let's use our quotient rule and split these up. So in my numerator, I have the cube root of 81. In the denominator, I have the cube root of 8. Oh, that's great, because that's going to simplify. All right, 81. I need to know what perfect cube divides into this. 81 is 27 times 3. So, and I can find the cube root of 27. So let's split it up into the cube root of 27 times the cube root of 3. In the denominator, the cube root of 8 is 2. Let's go back here. The cube root of 27 is 3. So I have 3 cube roots of 3 over 2. And I didn't even need to rationalize my denominator because it rationalized itself. All right, in letter G, we will have to do it though. All right, we've got 4 over the cube root of x. I can't simplify the cube root of x. What can I simplify? The cube root of x to the third, right? So how many more x's do I need? I need x squared. So here's what I'm going to do. I'm going to multiply by 1, but my 1 is going to look like this. The cube root of x squared on the top and bottom. And the reason I'm using this is because on the bottom, what this is going to give me is the cube root, using my product rule, of x to the third. Just multiply across the numerator. So 4 cube roots of x squared. All right. On the bottom, the cube root of x to the third is just x. And in my numerator, I can't simplify anything. So let's just carry it over. And just keep in mind, you can't cancel anything here because this is under a root and this is not. You can't cancel something that's under a root with something that's not under a root, all right? So don't try to cancel in that way. All right, let's take a look at h. And again, we're going to have the situation where we have to rationalize the denominator. But this is the square root, and the square roots are always easier to rationalize because you just use the denominator. All right? So we're going to multiply by 1, but our 1 is going to look like this. The square root of 5a over the square root of 5a. In our numerator, this gives us 12 square roots of 5a. In the denominator, the square root of 5a times the square root of 5a gives us 5a. And if I look at what's in front of the roots, there's nothing I can cancel here, so I'm done. All right, let's take a look at I. This is another cube root, so this will be a little bit more challenging. 5 does not divide by 4, so I'm going to use my quotient rule to split this up. So I'm going to have the cube root of 5 over the cube root of 4. Now, I can't find the cube root of 4, all right? But here's what I can find the cube root of, 8. And in order to make this an 8, I would just need to multiply by a 2, all right? So that's what I'm going to multiply by. Here's the issue. I'm really multiplying by 1, so I'm not changing anything. But the way I choose to write my 1 is what's important. So on the bottom, I need a cube root of 2. So put the same thing on top. All right, multiply across on the top. This gives me the cube root of 5 times 2, which is 10. On the bottom, this gives me the cube root of 4 times 2, which is 8. And that cube root of 8 is just 2. So this simplifies to be the cube root of 10 over 2. And remember, you can't cancel the 10 and the 2 because the 10 is under a root symbol and the 2 is not.